Hello, I'm Pete Starkey at Real Time with IPC. I'm out on the show floor. I'm at the booth of ScanCAD International, and I'm delighted to meet Bill Loving, who is president of ScanCAD. Bill, thank you very much indeed for joining us this morning.
Pete, it's a pleasure. Thank you very much.
Bill, looking around this show, there seems that lots and lots of equipment, lots and lots of automation. Is there any area of the electronics assembly process that, in your view, has been neglected or overlooked?
Yeah, actually there is. If you look around the show environment, any of these shows, it's quite obvious that most of the investment is made in really high volume production equipment. That is where really the focus of most of the equipment vendors and certainly the customers looking for equipment. That's where they're really focused today. And that means that there's some things that are sort of missing. So there are some openings and some opportunities, especially with the newer technologies that are out there.
Yeah.
And so, yeah, I'd like to share a little bit about that.
Yeah. Well, if you could give us a couple of examples, that would be really interesting.
Okay, very, very good. The two that come to mind, in fact, I'll use a sample here just to sort of show this. As a matter of fact, it was an SMT magazine article from 2006, April 2006, that talked about this, a Motorola study. So it's published and out there. It's just that no one, it's like flew below the radar. So, but essentially it's just one example, very simple. And we call it pre-production process control. But essentially when a circuit board comes in for assembly, the concept that the Motorola study pointed out is don't make the stencil until after the board comes in. When the board comes in, this job lot of board, lay the CAD data on top of the stencil, verify everything's okay, and then tweak it if necessary, especially for the fine pitch devices, before you make the stencil. Then make the stencil come in and go. You know, if you look around the equipment here and with the customers here, essentially most of the time a board comes in, the stencil was made long before, they come together, and where do they come together? On the production floor.
Yeah. And if there's a problem, that's the time you don't want a problem.
You don't want a problem, not with 8 hours of setup and all that kind of thing. Yeah. Now this seems relatively simple. It hasn't been addressed. It is an opportunity for everybody to take advantage of. And there are many systems out there that will do this, that you can actually do this measurement and check and get things lined up. Now the study pointed out was a 43% reduction in solder paste defects.
Yeah.
So that's just one simple concept there, verifying the stencil matches the board before production.
Yeah.
So we call that pre-production process control.
Yeah.
So pre-production process control. It's great results from that.
Yeah.
So that's one example.
Yeah. Another example?
Another example. The second example, and again, this is something that's just happened the last few years now, is the work instructions.
Yep.
The instructions that tell people what to do, step by step by step. Traditionally, work instructions, and our estimates are around 90-95% of the work instructions are on PowerPoint, Word, and Excel. Very difficult to handle revision control in those environments. Possible, and certainly everybody's doing it, but it's really awkward and it's very, very difficult. There are packages out now where you can get paperless, interactive, collaborative work instructions. What does that mean? It means that the operator only sees the work or the step that they need to be working on. It means that it's in their language. All right? You don't have this massive stack of documentation that's a traveler with all these drawings and stuff. No. You only see that one step. You can select which language you want to operate in. You perform that activity. The system tracks how long it took for that step, who worked on it, what they did. It even will collect measurement data. Again, as I said, collaborative real time. So that all goes into record for full traceability. Now that's new. That's very exciting. And again, there are a number of folks on this floor that are stepping into that now. These weren't available 5 years ago. So this is, you know, it's a new way of looking at things.
Yeah.
Okay?
No, I say it's just nice to have a bit of application of lateral thinking, and it's a perception of, I think, a perception of the obvious that.
It is. Well, what I like to say is, and this is true, is no one goes to work with the intention of creating a problem or having a boo-boo or making an error, right?
Yeah.
Yet we do have problems out there, and so if we can provide again, that perception area, but if we can provide the tools necessary for folks on the floor to get their job done, to really support them or what they're doing, and again, making it simple, just simplifying complex technology. That's, again, what ScanCAD's all about, is simplifying complex technology. So, again, whether it's ScanCAD or another company, that whole process control area, there are some things that can be done in front of or behind these really neat automated systems.
I think that sums it up very nicely, just those three words, simplifying complex technology. And I say, you've given us just a little sort of lateral thinking insight, Bill. I'm very grateful to you. It's great to have met you, and thanks very much indeed for your time.
Well, thank you for your time. Thank you very much.
It's a great pleasure.
Take care.
Pete Starkey, Real Time with IPC. Thank you.